All right, and welcome to lesson 3. We're going to be looking at the zero power and using your calculator to solve some of these equations and help us along the process. So the first thing we want to look at is the initial value. And the initial value is very similar to what we deal with when we're dealing with y equals mx plus b in linear equations. The equation changes, but it's still important to know where does it start and how does it change. So the starting values on exponential function, if you take a look at these examples, 5 to the 0, 7 to 0, 10 to 0, just go here, 5 to the power of 0, what do you get? 1. 7 to the power of 0, what do you get? 1. 10 to the power of 0, you get 1. Even just throw the x to the power of 0 on there, you get 1. Anything to the power of 0 is going to give you 1. So we're going to start there, and it's just an important piece to know. And that's going to be the initial step. So it says recall in the previous examples how it's going to be helpful to find the zeros. If we look down here at our examples, when we start at 0, 3 to the 0 is 1. So this function right here, number 2, is going to start at 4. This one's going to start at 3. This one's going to start at 7. This one's going to start at 5. So it's nice because that number out front is just the starting point. This right here tells us how much it's growing. But this number out front is going to tell us a starting point because when you multiply by 1, you're just going to get back to the original number. So let's look at creating one of these tables. So go over to your calculator over here, hit the y equals, just turned red. And let's put this in there, the 5 times 2 to the x. So you can do this 5 just the way you see it, parentheses, 2. If you want to get to the power of x, use this little up arrow key here, right below the clear, to the x. And this is important to note here to just kind of take a pause and stop. See how this cursor is up here next to the x. We move the right arrow or the down arrow and bring it back down again and then close the parentheses. If you don't do that, what will end up happening is you see that little mini thing up there, and it can kind of screw up the way your calculator calculates. So when you're done with what you want to put the power on, just click the over button to bring that cursor back down, close your parentheses, hit enter. Now let's take a look at the table of values. So again, it starts at 5. Why? Because 2 to the 0 is 1 and 5 times 1 is 5. So if we wanted to fill out this table, 0, 1, 2, 3, 4, I'll just go out to 4, starts at 5. And now see this 2 to the x, this means it's multiplying by 2 or doubling. So 10, 20, 40, and 80. So you can use your calculator to create nice and simple tables. Now the rest of the tables I'm going to leave to you, so pause it for a moment. See if you can put these on your calculator and get the same solutions I have. Now hopefully you took the time to pause. This is 2, starts at 4 and triples, starts at 3 and multiplies by 5. Sorry, this should be a 15 right there. And then this one starts at 7, goes up by 2.5 each time. Those numbers get pretty big pretty fast. So real quick, I just adjusted these and made a mistake prior when I put this in, but these are the correct answers here for these solutions. So what patterns do you see in these tables? How are they related? Really what I want to do is talk about just the function rule itself. So this is the general rule, a times b to the x. This is how it starts. This is where it starts. It's important that that is the starting point or the y-intercept. If we want to use our terminology from the previous unit, and this b is the growth or the change. Now, how would you explain the difference between the functions 3 times 6 to the x and 6 times 3 to the s? This one starts at 3 and multiplies by 6 each time, where this starts at 6 and triples each time. And it's just important to understand in these examples, this is the starting point and this is how it's changing. So it starts at 3, multiply by 6, starts at 6, multiply by 3. Good luck.